In this video, I want to do this integral again, but this time I'm going to do something that's not wrong, but it doesn't lead you to an answer. So just in case you run into it, you see what might have happened here. So this is an integration by parts. I recognize that in that it's a product of two things, and one of them is clearly not the derivative of some other part of the other one, so a u substitution is not working. So anyway, u du v dv. I am, like I did on the last one, trying to avoid that negative sign. I'm going to put a sine of 3x as u and a e to the 2x dx over here as the dv. So I'm going to take the derivative of sine of 3x to get 3 cosine 3x, and the antiderivative of e to the 2x to get 1/2 e to the 2x. So integration by parts tells me u times v, 1/2 e to the 2x sine 3x minus the integral of v du, so minus the integral of 1/2 e to the 2x times 3 cosine 3x. So let's make that a 3 cosine 3x. Okay. Now, well, like we said before, this is different than the integral we started with, but not necessarily any better. So I'm going to do integration by parts again. I'll pull the 3/2 out in front. So actually, let's just do that now. There we go. So I'm going to do a u du v dv. Again, it doesn't really matter whether the e is in the here or there, the cosine here or there. They're easy enough to integrate, differentiate. But I think this time I'm going to put the cosine down here. Again, thinking in terms of I don't like negative signs, so I'd rather take the antiderivative of cosine than a derivative, because the derivative will give me negative sine 3x. So I'm going to opt to do this. So the derivative of e to the 2x would be 2e to the 2x, and the antiderivative here would be 1/3 sine 3x. So integration by parts now. Let's see, I got an e to the 2x sine 3x minus 3/2 times u times v, so e to the 2x times 1/3 sine 3x, what just happened there? Minus the integral of v du. So 2/3 e to the 2x sine 3x. All right, let's distribute this negative 3/2 in there. So I've got 1/2 e to the 2x sine 3x minus, the 3's will cancel out, 1/2 e to the 2x sine 3x plus, actually the 3/2 and the 2/3 completely cancel out there, plus the integral of e to the 2x sine 3x. Well, back to the integral I started with, but what happened here? Wow, this and this are exactly the same, but with a minus sign in front of it. So this just boils down to e to the integral of 2x times the sine of 3x dx. Which tells me, what did I start with? I started with the integral of e to the 2x sine 3x dx is equal to, right? It's equal to that, it's equal to this. It's equal to itself, which is absolutely true. Means I didn't do anything wrong, but I didn't get the answer either. What happened? The thing is, the two integration by parts done in a row here, one had the trig function as u and the exponential as the dv. The next one was the other way around. Essentially, we just completely undid the work done on this first one. And this first one pulled out this part of the answer, and then we said, oh, but let's cancel that part out. By undoing what we did before. So we didn't do anything wrong. It's just it didn't lead us to the answer. Generally on these, it doesn't matter. You could do the exponential here or the trig function there. But whatever you do the first time, do the same thing the next time. Where I swapped here, it canceled out. Okay. Anyway, you may encounter that from time to time.